Science Live Chat. My name is Colin O'Connor, and is it just me, or are birds having a moment right now? It's fall migration. Birds are headed off to their winter homes in the south. More people are turning to bird watching as a way to engage with nature during lockdown. Last weekend, I personally added my 58th species to my lockdown bird list I've had going since March. And 3 research papers and 1 commentary article in the September 25th issue of Science show that birds have abilities beyond our expectations. Their singing talents are robust and adaptable to human-caused changes in their environments. Their brains are more like our own than we thought, and their brain signals even carry hallmarks of consciousness. So, with me here today to discuss these findings are Dr. Elizabeth Derryberry, Associate Professor of Ecology and Evolutionary Biology at the University of Tennessee, Knoxville. Hello, Elizabeth.
Hi, Colin.
How are you today?
I'm great. How are you?
I'm good. I was poking around on your Twitter earlier, full confession, and it looked like you were involved with the Girl Scouts. Is that right? Was I on the right page?
I'm a Girl Scout leader.
Great. And do you take them birding, introduce them to this stuff?
Yes, we have been. Not since the shutdown started, but usually when we go camping, I have a string of 26 girls and we're out doing things like birding and building campfires.
That's great. And are they, do you see them getting interested in this line of research?
Well, you know, kids are really interested in animals just to begin with, right? I think that that's one of the reasons I really enjoy working with younger kids, is that you don't have to convince them that a bird is fun or worth studying.
Right.
They think it's obvious.
Well, we can, I want to talk more about that in a little bit. Also with us, we have Dr. Christina Herold, Principal Investigator at Heinrich Heine University, Dusseldorf. Hello, Christina.
Hi, Colin.
How's it going? I saw something you wrote on LinkedIn, actually, about this paper that you've published in Science. It says, we have now seen for the first time a brain wiring in the sensory brain area of birds that is comparable to the architecture of mammalian neocortex. Bird brain, yes. Compliment accepted. Is this a compliment you're throwing around now to other people?
Yeah, I think so. So I explained it a lot, but I said, okay, if you're a bird brain, you're very intelligent and hopefully only a little bit crazy, but who's not? So.
And lastly, of course, we have Dr. Susanna Herculado-Hussel, Associate Professor of Psychology and Biology at Vanderbilt University. Hello, Susanna.
Hi, Colin.
Good morning. How are you doing?
Good. Happy to be here.
So I watched a video about you on YouTube that called you the woman who turns brains into soup.
Yes.
That seems pretty appropriate for Halloween season now. Is that something you're still doing?
Yeah, you'd be amazed at how much we learn about brains by just turning them into soup. Not eating them. Not eating them.
Not eating. Okay.
Not yet.
Well, that's actually kind of where I want to start. We have a couple very different papers here today, and I want to talk about them each in turn. And I wanted to start with some of your previous research, actually, not in this issue, but when I was in college, when I was a junior in college, and this was not all that long ago, I learned that the reason humans are so smart is because our brain is big relative to our body size, and it's that extra brain volume that lets us build the Taj Mahal or go to the moon or invent jazz, whatever. It seems like your research kind of turned that notion on its ear a little bit. Can you tell us about that?
Yeah, so this notion that the human brain is too big for our bodies, meaning that the body is a relevant reference, was important because back then it was the only way that that humans came out on top, because our brain is not the biggest brain around. It's not the most folded. It's not the most anything, unless you take the body into reference, and which didn't really make sense to me. I mean, who's counting? Who's keeping tabs on how large the body is relative to each species' brains? But once we could turn brains into soup and that way find out how many cells different brains were made of, then it turned out that not only there was enormous diversity in how brains can be put together. And what I mean by that is that two brains of the same size don't necessarily have similar numbers of neurons. It can be the case that a tiny little brain, like a bird brain, actually has even more neurons than a bigger brain, like even a monkey brain. And actually, the human brain, even though it is not the biggest one around, we actually do have the most neurons in the cerebral cortex. We have 16 billion neurons on average, and the next animal in line is a gorilla or orangutan with half as many.
So this is how my girlfriend is much smarter than me, even though her head is much littler.
Well, yes, things do not depend on size, but it's also what you do with the brain that you have.
And Christina, so this paper that you published here also shows something kind of surprising about the structure of the brain. What were you looking for with this paper?
So we looked for the fiber architecture in the paper, and there with newly developed methods like the 3D PLI or also finer techniques for tracing. We found that the fiber architecture in the bird brain is very similar to the neocortex, and therefore that the fibers and the cells are connected in the way that the canonical circuits in the human brain, for example, in all mammalian species in the neocortex, looks pretty much the same.
So the neocortex, where is my neocortex?
So it's all over your head. So maybe the prefrontal cortex, for example, is in front. Yeah. And then you have all these different areas all over the head where your neocortex is. Besides, in the back, there is the cerebellum. And there was always some, I don't know, in German, there was a complaining about if you want to activate your brain, you have to give some hands beside, but at least you would make this one to activate your brain better. Yeah.
So you were looking to see if birds had a kind of an analogous structure. Was that known already, or?
So no, not really. So we knew that birds also have a homologous structure, the pallium. So the pallium is homologous like the mammalian pallium, but there are some corresponding structures who are not directly in, there is no direct structure comparable to it. For example, the DVR, but it's also a somatosensory structure. That means that, for example, visual information that we have to work on is also part in this structure. And and so we see that in the somatosensory components and also in the hypopallium, which is comparable to other primary cortex structures in mammalian species. We see that the circuits, and especially the microcircuits, but also the long-range connections are similar, and the networks are similar, like in the neocortex. So.
You wrote oh, sorry, I think I was muted, sorry. Susanna, you wrote a commentary on this article and on another paper that we don't have a guest representing today, but was talking about neural correlates of consciousness in birds. Can you tell me a bit about that?
Yeah, so I think the thing that's so important about cortex or pallium, and that's why it's so important that Christina's work shows that they're really very much the same thing in organization, is that this is the part of the brain that I like to think that sits on top of everything else, and it receives copies of all the signals that are being processed everywhere else in the brain. And what it does is, because of that matrix of orthogonal connectivity that we knew that existed in the mammalian cortex, and Christina shows that you also find in the bird pallium or cortex. With that kind of orthogonal connectivity, you get new possibilities of making associations. You can put things together in your cortex that other parts of your brain can't. And that's how you can, for the very first time, you owner of this cortex with that kind of connectivity, you can start finding patterns, and you can start building representations of things in the world that maybe don't even exist out there, like how you feel about things, or what you perceive that is exists in your head only. And that's what the other paper from Andreas Nieder's group, also in Germany, found, that you have neurons, you can find neurons in the crow's brain that not only what we knew existed, neurons whose activity represents what is out there, but also neurons whose activity represents something that doesn't exist out in the world, which is what you perceive, what you later report, regardless of whether you saw that or not.
Interesting. So it's this kind of layer that sits on top of our brains that allows us to like almost have an imagination, kind of.
Yeah, and actually create perceptions, create things that really don't exist in the world, or that make inferences that your brain actually doesn't have. Like, for instance, the brain doesn't really receive information about where in the world a sound like a bird song comes from. That information that the bird is right there, like when you go bird watching, that's what allows you to watch, to look towards that place in the world, right? That signal that there's a bird right there, that is built by your brain. It has to be assembled together from all these the different signals that you have, and the perception you end up with that there is a bird of this kind located right there, that's built by your cortex.
I see. So if anyone listening has any questions so far, feel free to leave them in the chat. I hope to get to them. I know I have lots of questions brewing, but first I'd like to turn to Dr. Derryberry and your research. This is something that our listeners may have read about in the news. It seems pretty popular that in San Francisco during coronavirus lockdown, while there was less traffic, birds were performing better. Is that right?
Yes. So I think that one of the things we were really interested in was finding out whether people staying inside with shutdown were changing sounds. And so we did this by measuring noise levels and comparing them to noise levels from before the shutdown. And we did this specifically on the interior, right? So we wasn't really on a road. It was out in the air, again on the park, and we is it actually quieter? And so it's much quieter. And we wanted to know, how does that affect birds? Do they perceive that? Do they perceive that as a quieter? Change behavior in response. And so we wanted to hear what this looks like. We have an image of this bird, and we can see the white.
I'm sorry, Elizabeth. It sounds like we're having a bit of a technical issue with sound. I'm hearing it on my own. Maybe give Dottie a second to figure this out. Sorry a minute.
I think it's better wasn't showing the screen. So we could not.
Yeah, I'm still hearing it from myself.
There's still echo.
Is it better now? I feel like the echo's gone. Okay,
great. Wonderful.
Great. So I'll just move forward. So we didn't see, but we did see was a picture of actually one of our territories. So white-crowned sparrows is the bird that we were working on, and they hold territories right near the Golden Gate Bridge. And so you could see that sign showing that there's a shutdown in effect and asking people to space themselves apart. So that was one of the challenges of our field season, was doing this work while wearing masks, right, and moving through that landscape. So we did find that they changed their song, and they changed it in a number of ways. So you're right, their performance went up, but they also sang more quietly, which I thought was really interesting because we all heard more birds, right? It sounded like we've heard more birds, and wildlife became more apparent in our landscape. So it was a bit of a conundrum. How is that possible that they're actually singing more quietly, right? And I relate it to, it's kind of like San Francisco was a big cocktail party that just suddenly ended, right? So,
right.
Yeah, it's a big party. It's really loud. You're shouting for your neighbor to hear. You're probably at the height of the party. You're probably not saying anything really deep or philosophical. You're making small talk. And then the party winds down and people go home and it gets more quiet and you don't keep shouting, right? You actually start to speak more softly. So your amplitude drops. And the nature, the information that you can put into what you're saying goes up, right? So you probably do start having this sort of more philosophical debates at the party when it gets more quiet, because that's a fundamental thing about noise, is that noise forces this trade-off between being heard and containing information. And so, yeah.
What kind of, go ahead, Susanna.
Which sounds like one more proof that birds really do very similar things to us, right? They're listening to themselves and they realize that I can't get my voice through, so I'm going to have to shout. And when you shout, you bring your voice up. And of course, the content of what you can say is completely different. And as soon as you realize that, oh, I can hear myself now. They killed the music in the restaurant. We can have a real conversation now, right? So it's like birds, thanks to COVID, birds now have a nice, quiet restaurant to chat in. And literally, because they do get food from people, right, in cities.
Right. Well, and the thing is that what's interesting about their song is it's a signal that's actually long distance, right? It's we're talking over a long distance, and so it really matters when there's noise, right? It really does affect the transmission of that information. And with it being quieter, that means not just we can hear more birds, right? But they can hear more birds. They can hear more of each other, which means they can attract more mates. They can hold bigger territories, right? There's all sorts of things that they were allowed to do, at least in that little brief window of the shutdown, which just kind of miraculously, if you can call the pandemic a miracle, occurred during the height of the breeding season. So we really were able to see this.
No, I was just reading your paper, and I really like that part where you, you can really think of this as, like you were saying, like humans at a party making an effort to be heard, and all of a sudden things go quiet, and it's a relief. Oh my God, now we can hear each other. Now we can talk. And I like that particularly because this all happened within one season. So you cannot attempt to come up with some crazy utilitarian evolutionary explanation. Oh, the birds now became selected for there's this advantage to whoever happened out of chance to sing more quietly and in using lower frequencies, and now their voice carries over and there's an advantage. No, they're listening to themselves. It's that simple.
Yep. It's just the idea that behavior, right, is really a useful trait, right? It's really flexible.
Right.
It allows this rapid response, and it's really important, right? It's one of the key traits that allow animals to persist in sometimes maybe not the best environment, say like a downtown city, right? So that flexibility is really important. But we're curious to find out. So you brought in evolution, and I think a lot about cultural evolution. And that can happen really rapidly. And I want to know these young birds that are learning their song, during the shutdown, what did they learn, and what will it sound like next season? Will they just go right back to where it was before the pandemic, or could they potentially be in sort of a new acoustic space and the song evolving differently?
You know what? Maybe it's actually, maybe you could ask a similar question of kids who are now spending more time with their parents at home, and they're listening to hopefully more language, and not just that, more elaborate language, which is how I like to think of the baby birds that you're talking about, that are being raised in this new environment where there's less noise and much information. So they're probably hearing more complexity in their songs. They're probably learning to develop more complexity as well. So yeah, the world threw us a curveball that we can turn into tons of interesting experiments.
Exactly. I know it's a very interesting natural experiment, or unnatural, depending on how you think about it, an unplanned experiment.
Yeah.
Elizabeth, I'm curious how you, and maybe you addressed this when the sound got wonky, so apologies if I'm covering ground you've already covered, but how did you just define sound or song quality, and how did you measure it?
So we defined song quality basically based on what we know the birds are interested in, right? So the things that they respond to. So over the last decade, or actually almost 2 decades now, I've been working on white-crowned sparrows. And so I know a little bit about what females are interested in and what males see as a competitive song. And one of the things that are really important to them is this ability to sing rapid songs with a wide bandwidth, right? So the wider the bandwidth, sort of the more information it can contain. But also to be able to do that really quickly is challenging. There's motor constraints that are involved. So coordinating, song is quite a complicated motor task. And coordinating that is a measure of the quality of the male. So we know that songs that are higher performance are better, say, defending the territory. So we asked whether that feature changed during the pandemic, during the shutdown. So males were now able to achieve these higher performance songs. So what that means is that basically before, they weren't really achieving their full potential. Right? They had to narrow the bandwidth of the song just to get it transmitted, to reach others, but that then limited how much they could put into the sort of, I'll say, the sexiness of their signal. Right? And so because they didn't face that trade-off, they could be more attractive.
Which is very much what happens to us too, right? I mean, now there's little ambient noise here, so I can use the full range of my voice. And there's all this extra information that you get in what we call the prosody of the voice, the melody of your voice. And I mean, we don't understand what birds are singing, but we do get the part where there's a lot of melody. And of course, there has to be a lot of information in the melody. So imagine we were having this conversation just shouting. If we were shouting, we would be probably speaking like this, and then you lose that, you lose the range. Yeah. So there's much less that you can convey when your range is compressed.
Yep. Yeah, exactly. And so this performance value, and I think that was what's useful here in this study, also sort of supports this idea that it's important to study a system for a long time, right? Because if we hadn't already been working in this bird, if we didn't know what they cared about, if we didn't have these measurements from beforehand, right? If the NSF hadn't supported this basic science, we would not have been able to answer this question.
Right. That's a beautiful thing. I think also to bring up, because people, I understand the temptation to ask, well, why didn't you know this before? Why didn't you research this before? Why didn't you ask this question? It's like, we don't know what the questions are until the situation appears before you. And sometimes the only way you can address them is if you lucked out that somebody was paying attention and doing the experiments. And I have my little experiment going up right here. If somebody was curious enough to just be asking all sorts of questions beforehand. And that is the ground that we build on.
Exactly. And I think what's kind of interesting too is that we'd asked some of these questions before, and we'd done manipulations. Like we'd go out on a territory and basically blast noise at a bird and see what it would do. And it would change its signal to a certain degree, but not to the extent that we found during the shutdown. So we had predictions we could make, but what we found, it supported our predictions, but then went beyond it, demonstrating that it's not just the short, it's hard to explain, but it basically shows that this sort of whole landscape or whole soundscape effect, there's a network going on here of communication. It's not just this one signaler out by themselves. And if you change its soundscape, it changes to a certain degree. But if you change the whole signal network and everybody gets quiet, then they get even more quiet, right? It's like a collective chill out. and that sort of communication level effect, we hadn't even thought was there. So I think that's kind of cool. This gave us new insight into this idea. So now we can go ask more questions. Like now we can go say, well, what happens if we manipulate at a larger scale, right? Do we see the same effect?
We have a couple questions on our Facebook page asking about some of the questions that maybe you've asked already, or some of them that you might be getting into in the future. Carol Urbano asks, I've heard that in noisy times, urban areas, birds have started to drop lower frequency songs, and that has had long-term impact on mating. There's another question here about a territory. So were you able to look yet at how this change in song changes kind of mating outcomes, territorial behaviors, that kind of thing?
No. So that's something that we're hoping to do. There's been really beautiful work done on this actually in Europe with the Great Tit. So folks from like Wouter and Hans Saberkorn and Henrik Brum, they have been asking great questions with nest boxing species, where it's a little easier to track their reproductive success and to look at how noise is affecting it. And they've shown really great evidence that it has reduced fitness, that there is lower success in terms of how many chicks you have and how well they fledge in urban areas, and specifically in louder areas. And sort of some community level stuff has been done by people like Clinton Francis, who've gone out and manipulated soundscapes and oil fields and shown community level turnover. Like some species just drop out completely. They don't have the flexibility to change their signal. And so when it gets loud, they just go. And we haven't done it with white crowns because some birds are better at asking some questions. So white crowns are not as easy to ask about fitness because they're ground nesters. And so the cats just sort of all get them, right? So it's hard to disentangle the urban effects from the noise specific effects. Yeah. Good questions. Yeah.
I should acknowledge we did lose Dr. Harold. She was having some battery issues with her laptop, I think, and unfortunately we lost her. But so another question, and for people watching, keep the questions coming if you have them. I wanted to ask this question of all three of you. I'll do it for both of you. Does this research change your, or should it change your kind of ethical view of birds? If they're maybe smarter than we think they are, if they're more adaptable than we think that they are we kind of treating them wrong? I'll start with you, Susanna.
So this is a question that I get a lot from our work with a range of species, including cats and dogs and mice. And the question is usually put in terms of, so where do we draw the line? What number of cortical neurons is enough to give you consciousness? And the way I like to think about this is, if you have a cortex, if you have a structure that's connected like the cortex that sits on top of everything else and gives you this possibility of flexible behavior and complex behavior, chances are you do have some level of capability for consciousness, meaning for being aware of what's going on with yourself. So to me, the question is not where do we draw the line. The question is simply it's a much simpler thing of recognizing or of acknowledging that the possibility, the capability for registering, for realizing what is happening to yourself, is something that is common to animals. At least it's common to the warm-blooded animals that we've studied, birds and mammals. So I very much like the Buddhist approach to this, where you simply, there's no, you don't draw a line. You just be respectful of every single form of life. It doesn't matter how complex its cortex is or isn't. Sure, I'm convinced that the more neurons a species has in the cortex, the more elaborate its reasoning and its sensations and its feelings of itself can be. And actually, I started realizing that there's a very good example of something that we are still not good at realizing or feeling, despite our 16 billion neurons in the cortex. We still suck at realizing, at becoming aware of what's wrong with us, what's wrong with our body. Think of the day when you feel sick. You can say, I feel sick. But your doctor will ask, but what's wrong? What exactly is wrong? Even the simple, where does it hurt? It's just I don't know, it's something here. It's just not right. Think of that as a form of basic consciousness, that maybe one day there's going to be a creature that has 30 billion neurons in the cortex, and they're going to look back at us and just laugh at those puny humans who were never capable of spotting. Today, I woke up with a tumor bud in my about this, and they of course have the capability of doing that. So I'm not for drawing a line. I think understanding what a cortex does and what you gain with flexibility and complexity, and especially the part where the more you use it, the more you become aware of what this cortex can do for you. And
oh, Susanna froze a little bit for me. Okay, well, while she gets back on, Elizabeth, same question, and I think you probably have a good angle on this also from a conservation direction. So I'm really curious to hear what you have to say about this.
Well, it's interesting because people, have asked me this, like, what does this mean for the birds? And I always say, well, I think it really is important to think about what this means for humans. I think that one of the things that I learned from doing this work and talking to people was that when the sound dropped, when the noise levels dropped, when the soundscape sort of became more open, we loved it, right? For people, right? Just noise has an effect on our own mental health and well-being. And then people forget this, because when you're around it all the time, you adapt, right? You adjust, just like these birds. You adjust your behaviors. You get used to it. But in reality, it's causing quite a lot of stress on the system. And when it did get quiet, people were like, it was a relief, right? I kept hearing people say that. It's such a relief to go outside and hear and be able to, take a walk and have a conversation, but also to hear the birds, right? A lot of people really enjoy that. You saw all over social media, people posting about seeing animals or hearing birds and how great that was, not just as a distraction from the pandemic, but just as a moment of your life, right? Enjoying that. So I think that what's important from this work is it shows there's so many ways that we have screwed up our environment. There's so many steps we need to take to improve it. And this is one thing, the soundscape is one place where we can change our behavior. It's good for both us and the animals. Yeah.
Do we have Susanna back? I'm not seeing her. So we actually we had this scheduled until 1:30. Elizabeth, do you have like 10 more minutes? There's some really good questions on coming in from Facebook that I'd like to get to if we're able. And this one is probably a good one for you to answer. What's the scientific consensus regarding feeding birds in the winter? This is from Richard Tenney. Is that a good thing to do? Does it skew populations and increase dependency? Is that something that your research touches on at all?
It's not something that my research touches on. However, I will tell you that the white crowns in cities have higher survival than those in the countryside. And does have to do with feeders and having access to feeders. Now, so the question here is an interesting one, and I'll have to say that I don't think my answer matters, because people who like to feed birds are going to keep feeding birds. I like to feed birds. I put my feeders out. I like to see them. I think it's a part of the quality of life. In terms of the scale of the effect, it's kind of a net sum game where they get more food, but they also cost, like you go through the city and they go basically from one feeder to the next eating. So, right, you're also exposing them to more predation. So it's such a complicated thing to answer, and it varies depending on the species and depending on the location. So I personally feed birds through the winter.
Yeah, I got a new suet feeder the other day. I put it out.
So, I think it's hard to. I think the scale of the effect is probably. It's not as bad as all the other things we do in the city that affect birds. And in some ways probably balances out some of the negative effects.
Susanna, I'm glad to see we have you back. Can you hear me all right?
Yes.
Okay, wonderful. And do you have maybe 10 more minutes? Because we do have some good questions here from Facebook. Sure. Okay. There's one that I wanted to direct to you. This is from Richard Massacott. Hopefully I'm pronouncing that right. He says, we know some birds play, but can we say they actually feel joy? Is that something that we can ask?
I think we can. I think we can. That's definitely something we can ask. That's a very good question to ask. And I think that's a question that we can answer. Both behaviorally, the way they come back for things that when we do, we know that we enjoy them, we find them interesting. But this is where the anatomy comes in very handy again, because we know from studying mammals, from studying human brains also, we know what circuitry in the brain is involved with feelings of pleasure. There's a whole circuit that allows for the brain to detect when you do something that has interesting results for yourself. And your brain rewards your own successful actions with feelings of pleasure that your brain again causes directly on your body, this physical sensation of pleasure, and then it reads back these sensations that it caused, and that's the perception of pleasure and joy. And we know that this exact circuitry exists not only in birds but in other vertebrates as well. So the only reasonable, parsimonious thing is to infer that if they have the same circuitry, and also if they have a cortex on top that gets all the signals, all this information also from the body, then yes, they definitely must also have the same experiences of joy and satisfaction in solving problems and in meeting the other individuals that they like, that they care about, finding delicious food specifically, especially. That's something that we know that also drives this system. So I think we, in a number of ways, we have reason to say that the answer to that question is yes, absolutely. They should feel joy and satisfaction just like we do.
Well, that's a very heartwarming thought. Dr. Derryberry, we have another question for you. This is from Megan Phelan, who's here at AAAS. Not here, this is my living room, but at AAAS. Does your work showing how birds immediately change their song when noise pollution is removed suggest that anthropogenic noise may not have the same long-lasting legacy effects as other environmental pollutants?
Yes. Yes. So I think that the short answer is yes. I think that there are probably some long-lasting effects that we haven't measured yet, and that itself is an interesting question. But in terms of what we were studying, in terms of the behaviors we were studying, it does seem like it's transient, but it can be ameliorated, right? If there's less noise, they can kind of go back to a behavior that's more similar to birds in a rural area that have less noise. Mm-hmm. It's interesting with this question about pollutants, right? I think this is a question that is really hard to get at because it's hard to find pollution that you can then remove from a system, right? Like completely remove and measure the effect. And there are some experimental setups that have been doing this with chemical pollutions like in salt marshes. And they actually find that even there's a pretty quick recovery, faster than was thought to be. And so I think that that's something that scientists are trying to figure out right now with lots of different pollutants is what are the long-lasting effects and how quickly can organisms respond, and help even clean them up.
So we have another question from Rena Krautrith. Oh, I'm so sorry. I'm kind of butchering your name here. But she asks, is there research as to whether other birds, not just crows, have perception? And I'm wondering if this question relates to some of the things we were talking about consciousness earlier. Dr. Herculano Hausal, do you have an answer for that?
Yeah. So there are a few other species that have been used in research, and actually research specifically on perception. And pigeons are one of those species that people scoff at because pigeons, and the pigeons show an appreciation. They can tell faces from non-faces. They can tell objects from jumbled images of objects, and they're actually quite handy for research on perception. There's quite a lot of this research that comes out of Germany again, and they can be easily trained to peck at different screens or to peck at different parts of the screen depending on what they see, or now we know from the crows, depending on what they think that they saw, whether or not they actually were shown that is a whole other issue. So, yes, we know that there is other birds do have perception very much like we do. That also includes owls, by the way. There's a lot of research on sensory capabilities that has been done in owls.
So I think we'll have to end there, which is a shame because I want to hear more about owls. I've had my eye out for some urban owls recently, and I originally wanted to end by asking you each your favorite bird, but I think it's worth mentioning. We have two very impressive women scientists here. I know both of you are involved in mentoring young women and getting girls interested in STEM. So you can still tell me your favorite bird if you want, but I wonder before we sign off if you can tell me whatever advice you have for young women or girls getting into these fields where they're kind of vastly underrepresented. Elizabeth, do you want to go first?
Yeah, I think that it's really important to me to encourage girls to keep their voice loud. I think that girls are just like boys. All kids are born asking wonderful questions. And I have children and I have days when I say, please stop asking me questions. And I think it's important. And girls tend to listen and they shut up, and they shouldn't. They should keep asking those questions. So I encourage girls and the people in their lives to keep those voices going and keep them loud.
Yeah. Yeah, I'd say something similar to that, which is what I grew up hearing from my parents. Don't ever let anybody tell you that there's something you can't do because you're a girl. But I would extend that to just anything else. I think we should never let anybody tell us that there's something that we can't do because of who we are, whatever that is. Just yeah, keep your voice up. Way to go. I like that.
I'd love to hear Dr. Harold's comments on this. Also, maybe she can comment in the Facebook comments and let us know her thoughts as well. Sorry to have missed her, but that's all we've got time for. That is Dr. Susanna Herculano Hussel, author of "Birds Do Have a Brain Cortex and Think." That's in the 25 September issue of Science. Thanks so much for joining us, Susanna. We also had Elizabeth Derryberry, co-author of Singing in a Silent Spring. Birds respond to a half-century soundscape reversion during the COVID-19 shutdown. Thank you so much, Elizabeth.
You're welcome. Thanks for having me.
Of course. And lastly, we had Christina Harold, one of the authors on a cortex-like canonical circuit in the avian forebrain in that same issue of Science. Thank you for your time, Christina. Sorry we missed you. And that's all we've got time for. Thanks for joining. My name is Colin O'Connor for AAAS, and I'll see you next time.